Presentation is about improving performance of BCI speller using novel hybrid denoising approach based on wavelet transform and canonical correlation by Ms. Nadia Aqili.
Color
Please.
patterns to control external devices without using muscle. The BCI used for controlling robotic arm, wheelchair, cursor, car, smart home, and a speller, which among them, speller system are commonly used. The speller application enables a person to spell letters using their brain signal without the need for muscle movement. The important criteria for evaluating this application are accuracy and speed of the spelling. The BCI system are divided into three types, including invasive, semi-invasive, and non-invasive, which among them non-invasive commonly used. There are different brain signals based on non-invasive BCI types, such as electroencephalography called EEG, magnetoencephalography called MEG, and functional magnetic resonance imaging that called fMRI. The EEG-based BCI systems that receive extensive attention due to their advantage, including low cost, availability, and high temporal resolution. This study utilized the dataset of the fourth Iranian National Brain-Computer Interface Competitions dataset that used the hybrid sphere based on P300 and the steady-state evoked potential called SSVP signals. P300 ERP signals, I mean event-related potential signals, are the positive potential in the EEG signals that occur approximately 300 milliseconds after task relative event in an oddball paradigm. A steady-state visual evoked potential, or called SSVP, as the most widely used this pattern in an oscillatory signal that is generated by off-on visual stimulation that requires the brain. There are some challenges for these two types of signal, including requires more trials to achieve high accuracy, and another one is artifact and low SNR, signal to noise ratio due to non-invasive EEG. So we need a strong algorithm to overcome these challenges. Okay. First, it's better to briefly explain what is the triple RSVP speller. In the triple rapid serial visual presentation that called RSVP speller paradigm, three different characters are randomly displayed at the same location on the screen. So they are gaze independent, and the subject should look at the three characters at the same time in experiment. Uh, when the subject observes the target character, the P300 component appears for those letter. Therefore, we have a P300 classification for this type of paradigm. The protocol presented in this study is a combination of the triple RSVP and SSV paradigm that is shown in this figure. Uh, Using the SSVP properties, the target direction is detected. And by using the triple RSVP protocol, the target stimulus is recognized. For the design of the triple RSVP protocol, 27 alphabet letters are divided into 9 symbol groups. Each symbol group is shown as a stimulus, and each trial consists of 5 time repetitions of the 9 randomized stimuli. The symbol group and position of each character are unique in all repetition of the trial, and just the order of the stimulation display chain repetition, so that the stimuli are randomized as presented in the oddball paradigm. In addition, for the SSVP design, a flickering white square is placed in the center of the screen, which is surrounded by three characters on the three side of it. The flickering frequency is 15 Hz. By analyzing the spatial properties of the brain response to this flickering frequency, we can recognize which of characters is in the symbol group is attended. In the protocol, two different classifications are performed. In the first classification, the target symbol group is identified between nine classes. In the second classification procedure, by using the SSVP stimulation, a three-class classification is performed to specify the direction of the target character. The experiment begins with the fixation appearance in the center of the screen for 2 seconds in order to preparing the user. Then at the top of the screen, the three characters that will be spelled in a run are displayed for 2 seconds. And evaluation and the target character of the trial is presented for 2 seconds. After that, 45 stimuli are presented one after another and simultaneously a white square located in the center of the screen filtered at the 15 hertz. About the data recorded, this experiment was recorded using 32 active electrodes in accordance with the International 1020 system. You can see in the picture. The sampling rate of the signal was 50, 500 hertz. All channels were used for P900 analysis, and only 9 channels, which were marked with the red circle that cover parietal and occipital regions of brain, were used in the SSVP analysis. In this slide, first I introduce our P300 analysis. In this analysis, we have three parts contains a pre-processing, feature extraction, and classification step. In the pre-processing step, first the RSVP data was passed through a bandpass filter with a bandwidth in the range of zero point 0.5 to 25 Hz per year to beginning segmented into 900 milliseconds and decimated by a factor of 10. In the feature extraction step, due to the various response of different subjects to same P300 based paradigm, P300 signal requires a robust technique to be more applicable for all subjects. The Fischer linear discriminant analysis is widely used to find the projection matrix W. Um, you can see in this equation that maximize classes separability. Separability is measured with the Fisher's criterion, which is defined as a ratio of the between class scatter to the within class scatter, as you can see in this equation, where SFB and SFW are the between classes and total within classes covariance matrix respectively, and are computed as follow. Um, Since P300 based ERP signals have important information in both spatial and temporal domain, in order to extract the feature in the spatial and temporal domains, the two spatial and temporal projection weights are embedded that are called STDA, I mean spatial temporal discriminant analysis. You can see in this feature extraction block. Uh, the main idea is based on two projection matrices, WCH and WT, in the two dimension of spatial and temporal respectively, which map each signal X to a new selected feature with low dimensional offset. The matrices WCH and WT are optimized by the iterative algorithm, like this picture, and the algorithm stopped when the error criterion occurred. Following the extracted feature by the SDDA algorithm, we applied support vector machine that called SVM to classify the P300 signals. Actually, the target group was recognized in this step. For the SSVP analysis, signal with duration of 10.5 seconds were filtered by a band pass filter in the range of 1 to 47 Hz. As can be seen in this fig, three in the main fig. Three characters are located in the three regions of the flicker stimulus. By analyzing the spatial properties of the brain's response to this flickering frequency, we can recognize which of characters in the simple group is attendant. Therefore, canonical correlation analysis that called CCA was utilized to better recognize the properties by following a step. First, we create the reference signal of Y with a sinusoidal cosine signal of 15 Hz and its three harmonic as defined by below. I mean Y. Second, we find the projection matrix A and B to maximize the canonical correlation rho between AX and BY, where X and Y are the EEG and reference signal respectively. Finally, we apply the A Persian matrix to EEG signal to achieve a clear SSVEP signal. Following the artifact removing CCA process, discrete wavelet transport or that called the DWT was used to reduce the sampling size and remove the artifact. In this study, uh, we have applied the fifth decomposition level of Dubitsch's wavelet transform to the modified signal by CCA. Actually, the last tail coefficients of the DWT were used. And then use the LDA technique to calculate Y of the three SSVP classes. For conclusion, we introduced our algorithm in an IBCC 2021 and achieved the first place among the 83 group participants with a 92% and 75% 5 and 3 repetitions respectively. Just that. Thank you for your attention.
Thank you very much, Ms. Akili, for being on time and for your presentation. If there's any